Hello everyone, in this video we are going to start third lesson, that is kinetic theory of gases and radiation. In a previous videos we have learned about the properties of fluid. Now here we are going to deal with some extraordinary properties that are possessed by the gas. Before dealing with, if you are familiar, you must be have dealt with ideal gas equation. Okay. To study the ideal gas equation, two important gas laws were studied. The first law we called as Boyle's law. What was the Boyle's law? If you remember, at constant temperature, the pressure of gas is inversely proportional to volume. Therefore, PV is always equals to what? Constant. Along with that, we have learned with Charles' law. So according to Charles, at constant pressure, the volume of gas is directly proportional to its absolute temperature. So if I consider this, V upon T will be what? Constant. So if this is equation number 1, this is equation number 2, then if I combine both the equations, then I can say PV upon T is always what? Constant. So PV can be equal to K into T, or PV equal to nRT, where K is equals to nR. K is equals to what? nR, and R is called as molar gas constant. This basic theory you must have learned in the chemistry also. Now, using this analogy, we are going to prove some important characteristics of the gas. We are going to prove some characteristics of the gas, and we are going to call them as assumptions of kinetic theory of gases. When we describe the gas, what should be the contents of gases are there that were described with the help of this theory? We call it is what? Assumptions of kinetic theory of the gases. So what was the assumption? There are two assumptions. First is regarding the nature of gas. So nature of gas. According to this assumption, every gas consists of large number of small particles. Every gas consisting of what? Large number of small particles, and that particles we now called as what? Molecules. According to assumptions of kinetic theory of gases, that gas is made up of very large number of small particles, and each particle, instead of calling atom, now we used to call it as what? Molecule. Why molecule? Then we know that every gas cannot be remain in the single atomic state. For example, hydrogen never remains in the H form, it is always in the H2 form. So H2 is nothing but what? Molecule. Second, these molecules are rigid elastic spheres of very small diameter. These are what? Elastic spheres of what? Very small diameter. So their size is very small, they are elastic and as well as what? Rigid also. So how these both the words can equally used in the same sentence? So I will say, if you have seen the balls made up of thermocol, so if you consider that balls, they have specific size. If you compress them, they will get compressed. As soon as you release them, they will become the original shape. They will regain their original shape. So at the same time, they are rigid also and what? Elastic also. One important term that is told here, that the volume occupied by gas is very large as compared to original volume, or I can reverse the statement, compared to its original volume. Volume occupied by gas is very large as compared to, or उलटा I can say, गॅसचे जे ओरिजिनल व्हॉल्यूम आहे ते त्याच्या ऑक्युपाय केलेल्या व्हॉल्यूम पेक्षा खूप कमी असणार आहे. म्हणजे काय की मी समजा सायकलच्या ट्यूब मध्ये गॅस फिल केलाय तर ती ट्यूब एवढीशी तुम्हाला दिसेल, पण तोच गॅस जर या रूम मध्ये स्प्रेड केला तर तो रूम मध्ये पण ऑक्युपाय होणार आहे. सो ऑक्युपाय व्हॉल्यूम आणि ओरिजिनल व्हॉल्यूम यांच्यामध्ये खूप मोठा फरक असणार आहे. दिस इज अबाउट द नेचर ऑफ द गॅस. Okay, all the molecules inside the gas travel with the different speed. Now we are going to deal with one important term, that is randomness of the gas in terms of random motion. आता हे जे रॅन्डम मोशन आहे हे एक्सप्लेन करण्यासाठी तुम्हाला, इफ यू रिमेंबर, वी हॅव लर्न इन द प्रिव्हियस लेसन दॅट देर आर सम फोर्सेस विच होल्ड्स द मॉलिक्युल्स टुगेदर. वी कॉल देम मॉलिक्युलर फोर्स. आता हे जर मॉलिक्युलर फोर्स कमी किंवा जास्त प्रमाणात झाले, if these molecular forces are increased or decreased, then definitely there will be the change in the shape and size can be easily observed. In a gas, the molecular forces are very small. आता याच्यामुळे काय होईल, two gas molecules, if suppose they are contained in the container, if this is first molecule and if this is second molecule, तर या दोघांमध्ये फोर्स एवढा कमी आहे की हे दोघं कधीच एकमेकांच्या जवळ अट्रॅक्ट होणार नाहीत. Instead of that, they are free to move anywhere in that container. So this state we will consider as what? Random motion. So gas molecules are free to move anywhere in the container, inside container or inside vessel. का असं होणार आहे? कारण त्यांच्यामध्ये मॉलिक्युलर फोर्स कमी आहे. ओके, दिस स्टेट इज कॉल्ड एज अ मॉलिक्युलर केओस. त्याला मॉलिक्युलर केओस म्हणूया आपण. आणि या स्टेटमुळे काय होतं, दे कन्सिस्टंटली कोलाइड ऑन, as I said, they consistently collide on wall of vessel, neighboring molecules, etc. They first collide on neighboring molecules and then they collide on what? Wall of vessel. आता लक्षात घ्या की n number of gas molecules are filled here. Few things we are going to learn again in this part. इमॅजिन करा की तुमच्याकडे हा एक कंटेनर आहे आणि या कंटेनर मध्ये n number of gas molecules फिल केले आहेत. ओके, n number of gas molecules जेव्हा फिल केलेले असणार आहेत तेव्हा large number of gas molecules are there. In that case, if this is the first molecule, if it is free to move anywhere, so it is suppose going this side, so it can collide on this neighboring molecule आणि त्याच्यामुळे तिथं कन्सिस्टंट कोलिजन असणार आहे. या कन्सिस्टंट कोलिजन मुळे ते एकमेकांवर मोमेंटम एक्झर्ट करतील. सो दे इम्पार्ट्स momentum on each other. They impart momentum and that momentum exerts pressure on wall of vessel. That momentum exerts what? Pressure on the wall of vessel. Okay. एक महत्त्वाचा पॉइंट असा आहे की मी तिथे तुम्हाला म्हटलं, फोर्थ पॉइंट, इफ आय कन्सिडर ऑफ दिस थेरी, as I said, this is the first molecule and second molecule. It is colliding on the second molecule. So this is first molecule colliding on the second molecule. आता असं जर असेल तर हे मॉलिक्यूल कसे आहेत, मी म्हटलं इथं की ते आर इलास्टिक. So first elastic object collides on the second elastic object. There is no change in the velocity before and after collision. So kinetic energy of molecules is always same, always constant before and after collision. Kinetic energy of the molecule is always what? Constant before and after collision. Okay. आता सगळ्यात महत्वाचा, हा एक मॉलिक्यूल, हा दुसरा मॉलिक्यूल, हा कोलाइड होतोय. कोलाइड होताना न्यूटनच्या लॉ उभे होणार. लक्षात घ्या, एव्हरी इनॅनिमेट ऑब्जेक्ट कंटिन्यूज टू बी in the state of motion in a straight line. So हा पहिला पार्टिकल, पहिला मॉलिक्यूल जेव्हा दुसऱ्या मॉलिक्यूलवर कोलाइड होतो तर त्यांच्यामध्ये हा जो डिस्टन्स आहे, हा डिस्टन्स ऑलवेज अ स्ट्रेट लाईन. आणि हा जो स्ट्रेट लाईन डिस्टन्स आहे कोलिजन होईपर्यंतचा जो मधला डिस्टन्स आहे, that distance is called as what? Straight line mean free path. That is called as free path. So the distance is always what? Distance travel is always what? Straight line. Distance travel is always what? Straight line. And the distance between two successive collision, distance between successive collision is called as free path. त्याला कुठला डिस्टन्स म्हणायचा आपण? फ्री पाथ. ओके, बट गॅस मॉलिक्यूल डझंट कोलाइड सिंगल और वन्स ओनली. हा इथं कोलाइड झाला, इथून समजा तो इथून या दुसऱ्यावर कोलाइड झाला, तिसऱ्यावर कोलाइड झाला, चौथ्यावर कोलाइड झाला. सो इथं डिस्टन्स लॅम्बडा 1, इथं लॅम्बडा 2, इथं लॅम्बडा 3, इथं लॅम्बडा 4. ओके, हे सगळे डिस्टन्सेस जर मला फाइंड आउट करायचे असेल तर आय हॅव टू फाइंड आउट विच पाथ, मीन फ्री पाथ. सो व्हॉट इज मीन फ्री पाथ? Mean of all free path. So mean free path lambda can be given by lambda 1 plus lambda 2 plus lambda 3 up to lambda n divided by n. Okay, लक्षात घ्या, प्रत्येक वेळेला ते डिस्टन्स वेगवेगळे ट्रॅव्हल करू शकतात इन अ स्ट्रेट लाईन विथ different speed or different velocities. In a straight line with what? Different velocities. So this was our article today. If you revise that article in short again, then we can have some basic revision. First is the ideal gas equation. According to ideal gas equation, we are actually formed the ideal gas equation from Boyle's law and Charles' law. According to Boyle's, product of pressure and volume is always constant if the temperature is not changing. If pressure is constant, then volume and temperature are direct proportion. So combining both, you will get the equation PV equal to nRT. Here, R is molar gas constant and N is number of moles of gas. N is what? Number of moles of the gas. Then, to explain the characteristics of gas, we use some assumptions to explain. That assumptions we are going to call as assumptions of kinetic theory of gas. So what are those assumptions? According to that, the gas consisting of large number of small particles, and we call those particles as what? Molecules. How are those molecules? Then they are rigid and elastic sphere and having very small diameter or radius. They are very small in size. सगळे खूप लहान आहेत. लहान साईज असल्यामुळे दे हॅव व्हेरी हाय कॉम्प्रेसिबिलिटी. कॉम्प्रेशन खूप जास्त होतं, त्याच्यामुळे तुम्हाला जे व्हॉल्यूम दिसतं ते खूप मोठं आहे. प्रॅक्टिकली त्यांचे व्हॉल्यूम कसं असणार आहे? खूप कमी असणार आहे. सो ओरिजिनल व्हॉल्यूम इज व्हेरी स्मॉल as compared to which volume? The occupied volume. Okay, random motion. Gas molecules are always move inside the vessel or free to move inside the vessel. का free to move आहेत? कारण त्यांच्यामध्ये जो फोर्स ऑफ अट्रॅक्शन आहे तो एकदम कमी आहे. दोन मॉलिक्यूल एकमेकांना होल्ड करून ठेवत नाही आणि त्याच्यामुळे दे आर फ्री टू मूव्ह एनीवेअर इन द कंटेनर. दिस स्टेट ऑफ द गॅस इज कॉल्ड मॉलिक्युलर chaos. Because of this state, they consistently collide on each other and they collide on the wall of vessel. आता कोलाइड झाले, कोलाइड होताना त्यांची वेलोसिटी सारखी चेंज होत राहील, त्याच्यामुळे ते मोमेंटमचे एक्झर्ट करतील. मोमेंटममुळे फोर्स आणि त्या पर्टिक्युलर एरियावरती तो मोमेंटम चेंज होते, म्हणून तिथं प्रेशर सुद्धा एक्झर्ट होणार आहे. ओके, सो दे एक्झर्ट प्रेशर ऑन द वॉल ऑफ वेसल. अकॉर्डिंग टू कायनेटिक थिअरी ऑफ गॅसेस, ते इलास्टिक असल्यामुळे त्यांची कायनेटिक एनर्जी नेहमी कॉन्स्टंट असणार आहे बिफोर कोलिजन ऑल्सो अँड आफ्टर कोलिजन ऑल्सो. Distance which is traveled by them is always a straight line, and that distances are traveled with different speeds. Because of that, the distance between two successive collision, that straight line distance between two successive collision is called as what? Free path. Mean free path काय असणार आहे? तर अशी बऱ्याच वेळा तो कोलाइड होणार आहे. एका जागेवरून दुसऱ्या मॉलिक्युलला कोलाइड होईल, दुसऱ्याकडून तिसऱ्याकडे, तिसऱ्याकडून चौथ्याकडे भरपूर कोलिजन होईल. भरपूर कोलिजन झाल्यानंतर जे फायनल डिस्टन्स असणार आहे ते फाइंड आउट करण्यासाठी तुम्हाला मेन फ्री पाथ काढायला लागणार आहे. आय होप you understood this article. Thanks for watching mahasarkar.co.in. Have a good day.